This is PSSA review for global climate patterns. Here's some words to know that would be useful. Axis, latitude, longitude, Coriolis effect. If you don't know them right now, they will be mentioned in the text for today. So what factors create global climate patterns? The big idea. Global climates are created by a combination of energy from the sun and Earth's tilted axis. Air and water currents help circulate energy and create climate patterns. That's what we're going to be reading about today. Earth's movement accounts for many changes and patterns on Earth, including the weather. The unequal heating and rotation of Earth directly affect weather and global climate patterns. Weather is what happens in one area over a short period of time, while climate is a region's long-term weather pattern. Earth spins or rotates on its axis, which is an imaginary line that passes through Earth's poles. Each rotation takes about 24 hours, the length of one Earth day. Earth also revolves or orbits around the Sun. Each revolution around the Sun takes about 365 and 1/4 days, the length of 1 year. Earth's rotation explains why some daily changes on the planet. For example, the sun, moon, and stars appear to rise from the eastern horizon and set along the western horizon. This is because Earth turns around the east as it rotates. You can see this picture here. Faintly, you can see the word summer up here for the northern hemisphere, winter for the southern hemisphere. Here's the sun, and you can see that the northern hemisphere is getting direct sunlight. So that's why it's summer, because it's getting more direct sunlight, whereas the southern hemisphere right now isn't getting direct sunlight. That's why it's winter there. Earth's tilted axis and revolution around the sun cause changes, such as the different seasons that occur over the course of a year. The different seasons bring different weather. Lines of latitude and longitude form a coordinate or grid system that is used to identify locations on Earth's surface. Latitude lines on maps and globes show distances north and south of the equator. Lines of latitude circle Earth, running east to west, parallel to the equator. Longitude lines on maps and globes show distances east and west of the prime meridian. The prime meridian is an imaginary line that divides the Earth into eastern and western hemispheres, or halves. Lines of longitude circle the Earth, running north to south, and intersecting at Earth's geographic poles. Okay, so you can see the equators going here. Longitude are these long lines that go up and down. Longitude are the long lines going up and down. Latitude are the lines going left to right. Earth's tilted axis and energy from the sun create global climates. Air masses and ocean water currents help to circulate the sun's energy and create climate patterns. Air masses and ocean currents move in a predictable way because of a force called the Coriolis effect. The Coriolis effect causes objects with mass, like air or water, to rotate to the right in the northern hemisphere and rotate to the left in the southern hemisphere. This predictable movement of air and water helps account for some global climate patterns. Global climate patterns are also driven by a region's location on the planet. Higher latitudes, those from 50 to 90 degrees, receive less solar energy, direct light from the sun, than do lower latitudes from 10 to 40 degrees, resulting in temperature differences. Elevation also affects climate. In general, areas at higher elevations, such as mountainous regions, have lower average temperatures than do areas at lower elevations, such as valleys and deserts. Landforms, such as mountains, deflect wind and can force it to higher elevations. Smaller temperature changes tend to occur in oceans than on land. Because water can absorb more solar energy than land, there is a greater and more rapid temperature change on land. Therefore, the centers of land masses, such as cities in the middle of continents, experience more rapid temperature changes than cities near oceans.